tool. And so to address this, we've examined several different technologies, and I think we've settled on the neural glancer. And last week and the week before, we gave some updates on what that looks like, and we're making further progress toward that. Where I feel, Joel and I both feel like, and Art, we all feel like it's ready to now start. We're satisfied with what we're seeing, and we're understanding more about how it works. So we're feeling confident and satisfied with it, and it's now time to start plugging it into alignEM-SWiFT. So Joel has started working on that over the last couple of days, and I'm not sure whether he has anything specific on that to show today immediately, but we can at least say that we're getting ready to plug that in. And I think last time, let me move this out of the way.
Tom.
Yeah, go ahead.
So I presented my slides last week. I guess the only thing that I didn't get to was the prospect of potentially, I guess I did mention this, potentially branching or forking NeuroGlancer instead of working with the Python API exclusively. And that's something that we're considering.
Yep,
so
right.
Now that you're running the server here, maybe you can demonstrate the callback functions that I showed you. So
okay, well, let me
Kristen mentioned so while you're doing that, I'll just explain that Kristen mentioned last week that she would like to have a blend function. So I did write that as a callback function. So maybe you can demonstrate that now. And then the unchunk function, if you want to demonstrate that.
Why is this? What am I? Oh, okay. I was looking at the wrong. I was looking at this the wrong way. First, I want to show specific progress on here. So I think last week we showed you that that this is a single image, a TIFF image out of this stack, and this is what it looks like off the microscope, and its proper orientation here, and X and Y is shown here. And last week we showed you, last time we showed you that the image orientation was flipped about the Y-axis by 180 degrees, and so it was. It was kind of like a mirror image of this, but now Joel has fixed it so that now we have the image oriented the right way. And if you look at the X, Y, and Z coordinates, dimensions, or pixel size up here, I guess it says it's last week it said Z, Y, X in the opposite order. Now it says X, Y, Z in the right order. And if we look at the metadata for it, it says ZYX because that's the order of the data that's actually in the data set. But it says the Z is 50 nanometers, Y is 2, and X is 2. That's all correct. And the Z dimension is 269. That's how many images there are, and they're 24,576 by 24,576. That's all correct. All that information is correct.
I should add, this is important not just visually. It has to do with the efficiency of stepping across pixels between the original image space and the views that we see here.
Exactly. And so the order ZYX is important for efficiency of stepping through. But of course, we want the image to be displayed and the information shown here to be shown in an order that is the more common way for the person to think about it, that we have an X dimension, which is this red axis, and that the positive X direction goes from left to right. And the Y dimension is 2 nanometers, and its direction is the positive Y direction goes downward.
Which is obvious for us computer types, right?
Yeah. That really is how the Y dimension is in in raster images. That's the proper
So
ordering.
interesting, because you always think about the y-axis as going up, but it also goes down negative. You think of it as being down.
The rest of the world is upside down, Kristen.
Yeah.
What world is upside down?
The rest of the world is upside down.
Yeah. So for
Computerland, it's this way. And
comes
from the decisions made in the development of television early on.
Oh.
Yeah. But also, if you think about a written page, when you start writing on the page, you start at the top left.
And you go down. Mm-hmm.
And you go down, right? So
yeah. So you can't think of it like a y-axis. It's just a y direction in reading.
It's just a y direction in reading. And the order of data in the file is, this is the first pixel in the file. And this is the next pixel, next pixel, next pixel. You get all the way to the end of this row. And the next data is the next row from top to bottom. So that's the order of the data in the image, right? So that's that, right? And then Z the Z dimension is going inward into the page, I think. The Z direction goes inward. So this is the first image, the second image, third image, fourth image going into the page. I think it goes into the page. Maybe it comes out of the page. I don't know, but it's got some order. Okay. So all that's correct now. And Joel has added to demonstrate some functions that are driven by the keyboard, extending the functionality of NeuralGlancer using Python callbacks that are tied to keys on the keyboard. Joel has set it up so that, so Joel, maybe help me with this for a second.
Yeah, so.
Let me go here.
Can you let Joel share the screen, or are you?
Yeah, maybe Joel, would you want to show it by sharing your screen?
Yeah, let me.
Okay, and I'll stop sharing.
Sure. Okay.
And Joel is really picking up things very, very fast. He's been picking things up very fast, and now we're back on this curve. So it feels really great. And Joel, I hope Joel, you feel the same way. That it's been a lot of fun, and it's about to get like super extra fun.
Yes.
And I'll add my double up to that as well.
Okay.
No, good to have Edwin recovered from his COVID booster.
Yeah.
No, I'm back on, and
good.
I've been very tuned to the work being done on ZAR with Joel, and I heard a few minutes ago that you might be starting to connect the two parts, the current user interface with the NeuralGlancer. So that's where we are on this end. So I'll touch base with you, Joel, via email, and then we can probably do a quick, a few sessions because we are basically working right now on the same. So
yeah, and then we can start to move to talking about the infrastructure attack.
Absolutely.
Yeah.
So I wanted to demonstrate one thing, which is, Kristen, you mentioned it'd be convenient to have a blend function. So I did write a function where I press B on the keyboard, and then we'll get the blend of this image and the next image, just for a quick glance at that.
And maybe
what key are you pressing to do that?
I set it to B for blend, but if there's another key that makes more sense, then I can change that.
The space bar and the / are the ones that we normally use, because B has a lot of other functions associated with it. So the space bar is the blend, and the / is the flicker. Like if you want to go between the two sections without actually having them blended.
Oh, so we can do that with comma and period. So go on forward, back. Yeah, we can change these key bindings.
Yeah.
Okay.
So the comma and the period are the default ones for going forward and back in NeuralGlancer.
Okay.
I don't know why they chose comma and period.
And I don't understand why they would need
the left and right arrow.
I don't understand why you need two anyway, because you're just going back and forth between two images.
Well, no, the dot goes forward and then forward again and then forward again and then forward again.
I see.
right.
See.
So
it's a page up and page down.
Yeah, page up and page down. But we could make one key that says the
just
next
flicker
one
between two adjacent.
Just flicker between this one and the next one, or I guess.
Yeah,
right?
that turns out to be a very useful tool when you're learning or when you're trying to interpret complicated images.
Yeah.
To be able to just flicker between, you don't want to have to keep going forward or going back. You want to flicker between two that are in memory, basically.
Yeah, exactly.
As though you were blending them, but you have two ways to look at them. One is blend and one is flicker.
Yeah.
And by flicker, I mean, if you were to hold it down, it would flicker fast. When you hold it, it goes faster and faster.
Sure.
If you press it one and again and back and forth, it'll go back and forth between those two images at the pace that you hit it. And then the blend obviously gives you a full-on blend. And the blend is extremely useful too. When I look at any alignment, I literally turn on the blend and then I page through it with the blend on. So you get to see two adjacent sections and you instantly see where one comes out. So that tool is extraordinarily useful in testing alignment. I mean, obviously, you're putting in automatic tools to tell us, how good is the alignment? You're going to have the white spot and all of that. But retaining that manual tool so that somebody can say, did I do something to the alignment here? Or what's going on?
Yeah, exactly. Yeah. So we discussed this a little bit yesterday that, when everything goes well, you hardly have to do anything, right? But you need diagnostic tools for when things don't go well, and you need a way to figure out, what went wrong. I don't know what went wrong, and was it this, was it that, and you have to look at it lots of different ways to figure it out sometimes.
Yeah, exactly.
Yeah,
fantastic. So anyway, thank you, Joel. That was a nice demonstration of blend, and then of course the period and the comma and the blend. If you basically do whatever it is it takes to do back and forth to a single key, you will have already created several functions that need to go into Reconstruct Plus. It's there. Boom.
And then there was one more thing, Joel, maybe share your screen one more time to show show that you can export the current image as a file.
Sure. So it starts in the middle of this stack. So if you look at the Z right there, the Z dimension, it shows I'm on the image 97.
Yeah.
Then there's 190 something images. So let's say I'm on image 82 right here, then I use the U key, which stands for unchunk. So if I press that, then we'll see the directory that I'm working in. We get the unchunked version of it. And we can also do this in different scales. By default right now, it's just it's unzarring it, basically. It's unchunking it, but I'm unchunking the scale 0 image, so the full resolution image. And I guess this is also a good demonstration that this is lossless compression, so it's all reversible, the compression. So it's not a scary word, we're not fundamentally altering the original images.
So here's as you demonstrate this, of course, I can tell you something that we find extraordinarily useful. I'm so glad we're getting really close to integrating with Reconstruct Plus, because, we've all been using it really intensively for the last few papers. And so we've come to know all the keys and the hotkeys and the strategies that we use in Reconstruct we want to re-implement. And a lot of them have to do with viewing. So it's interesting that it puts, you to the center. And one of the things that you'd like to be able to do is to hit one key that zooms you out to the center, zooms you out to full screen.
Yeah.
We hit the home key. But also if we do control home, it centers you on the trace that was selected.
Yeah.
And so that zooms into it.
So that would be doable because that's represented in a JSON file called the .z array, and that's got the current state of the viewer, which includes things like offset and resolution. And so that's where you can that can be, that would be easy enough to bind to a key press to change things about the view, because this is just changing the state of the viewer. So
that's fantastic. Wow, that's really neat.
I'll make a note of that.
Yep. So if you want to use the same hotkeys, Joel, that are in existing Reconstruct, it might be, I mean, it might be just sort of time savings from the point of view of people who are familiar with Reconstruct to use the hotkeys that Reconstruct has in it, because everybody's, you know, I mean, they're programmed to my fingertips right now.
Yeah.
and a lot of people's fingertips. And then we could have a discussion from the team at some point after you've had a chance to look at those hotkeys. If you let me share my, oh, you want to show something more here, Joel? Is that what you're watching?
No, that's about it.
Can I have the share screen? And then I can just give you a little show on where you can easily find this in Reconstruct. Sorry. You might already know, but I suspect that's, so if you open Reconstruct and then you see it gets loaded in the help key commands. It's also in the manual, but this window basically tells you what all the hotkeys are and what they do.
Okay.
And a lot of them have to do with what you're doing right now. You know, zoom to the slide. This is the control. This is the, okay, so escape means abandon current drawing. Well, but anyway, then the home key is what I was telling you about. Center the section image in the view, and it centers the whole image with home, but control home zooms into selected traces at some zoom level that you can preset if you want to. And then each of these other things performs useful things either while you're tracing or while you're viewing or while you're doing things. So you might just want to take a look at that and see which of those things, you know, there's already stuff existing in NeuralGlancer that you just program into Reconstruct Plus on a hotkey as you work with Edwin and his creation of the infrastructure that's going to be in Reconstruct Plus.
Yeah, sure.
Does that make any sense at all?
Yeah, definitely. Consistency.
Now, I would say, let me just tell you that the main window hotkeys, almost all of them are used. Let me just see if there's anything that's not used. No, and our manual defines in ad nauseum detail what all these things really do and what the underlying code is and blah, 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 if you want to look at that. So you can get that from the download. I'll show you that in just a moment. The wildfire tool is sort of intended to be an object by object auto segmentation. It works great for people who've done like camera lucida drawings and they just have black lines. It has, you know, just like what Arlo's trying to do, you know, with EM images, it doesn't work very well on EM images. So I would say this is certainly something we want to be able to do. Pick an object and say, okay, give it to me in 3D. I also think C3 Deep, according to Mark, does that already too. So these are the things that we might want to just think about reaching out to our Mark Ellisman, in C3 Deep. And then obviously there's the contrast adjustment for the brightness, and these values actually get stored with the image as it gets changed, the domain image. So for example, if I were to go into a series and let's just open a series. Here's another thing that I think you might find interesting if you haven't done this before. You'll notice that right now, all that's coming up are the traces, right? But if I wanted to, it's because this particular series, I've turned them off. But if I wanted to, let's start over again. Let's say I'm going to change this to options. Hold on a second here. Not going to hide the domains. I'm going to unhide domains. Okay, and then I'm going to just exit for a minute here. And go back out again. That was kind of a special case, so I just wanted to show you what it normally would do. If I open this now, notice how it says, I can't find the images because all that I've done is open the trace files. It has a function so that I can have the trace files separate from the image files, where I can say, well, okay, we'll find it. And then it lets me go out into another folder. So I only have one folder with images, but I've got 30 folders with trace files in them from the same images. So now I can just go out and find that image. And in this case, it's image number 13. And so I can go find image 13. And now by just finding that one image, it found them all. And now I can just page through the images, right? So that function turns out to be extraordinarily useful so that you don't have to have multiple versions, something like that. So you don't have to have multiple versions of the images, even if you want to have, lots of trace files talk to those images. All right, so that's, I was just kind of showing you a little bit more on the hotkeys, key commands. Now, also in Reconstruct, there's a bunch of transforms that have to do with alignment. I would argue probably we don't need to leave any of those in there, that you would work with alignEM-SWiFT in its environment to fix alignment, not in Reconstruct to fix alignment. So all of this component of these tools has to do with alignment, basically, and transformation to be able to do the alignment. However, it's useful to be able to still have up and down and right and left movement around in the images, which you guys do already. So that, I think that's kind of a whole area that's not really needed. And then there's a bunch of other windows that have their own hotkeys associated with them. But I think the first set in the main window is really what's relevant right now to your thinking about integrating NeuralGlancer and imaging and the functions that you're superimposing in NeuralGlancer for image manipulation using similar hotkeys to what are present already in Reconstruct will really be a useful tool. I realize that I can't blow this up much. Oh, yes, I can. Look at that. I can.
Oh.
Look at that. I didn't know I could do that. All right. It's letting me do it. Okay.
There you go.
I wonder if I can always do that. I'm just using a control roller, just like you do, with Windows. So there we go. Sorry. So anyway, these are the main window ones. Just about all of them turn out to be useful. So why not use the exact same thing? Okay. So you might ask me, so open the trace attributes dialog of traces that are selected. So if you're not familiar with Reconstruct, that would be confusing. So I'm going to do a control A on here. Now let's see. I don't think I can zoom in on this guy. I can't. It was just that, it's just the help I could zoom in on. But anyway, it will open this folder that tells me every attribute on that trace that I selected over here in the window. And it tells me its name, its color, whether or not I want it hidden, whether or not I want it simplified, closed, or if unclicked would be open. Should it be filled? When should it be filled? What are the fill's features? None, darken, solid, lighten. And then there's a comment. And the comment, usually so Edwin and I have talked about this a long time ago too, that it'd be very nice that every trace receive a stamp that indicates the date, time, and username who created that trace, with a list of list of who modified it as well. Right now, I just force people to write that into the comment. Like, okay, today is, whatever day it is, 24 already. Oh my, 27. 24 already? No, it's 27. And I would just put that in there so I know that it was me who did these traces, and then you can apply it. So anyway, there's a lot of cool things in here that are going to be implemented, in Reconstruct Plus, but some of them really, you might want to just implement in the NeuralGlancer environment, and Reconstruct just makes a call to them. Does that make sense, Edwin, the way I'm talking about this?
Yes, I have thought of a couple of ways, because in thinking of Adobe Lightroom kind of resemblance, you can have all that metadata kind of automatically plays from whoever is, let's say, logging in or whoever is using that. So it can be logged out automatically as opposed to having to type it in all the time.
Yeah.
And I'm thinking in a future, at some point, you could have multi-user collaborations in which the stamps will get placed without the user's explicit typing.
That's right. And I think that's how C3 Deep works too. I'm not sure if anybody else has used that in Mark Ellisman's group. He's
looked at it. I think Andrea as well at some point.
Yeah. And I jumped a little bit ahead of you, but yes, thank you for answering that question. But I think it makes sense from the point of view of what Joel's working on now for him to go through and see which of these hotkeys should be embedded, and take advantage of keys or tools that are already existing in NeuroGlancer, and then be able to extract them into the user interface in Reconstruct Plus, because you know how to do it.
Yeah, absolutely.
Does that make sense to you, Joel, what I'm saying too?
Yeah, definitely. And I've screenshotted when you had the full list up. I took a screenshot of that and saved it.
And so then let me just go one step further to show you where you can get access to Reconstruct, in case you haven't already done so. But I think it would be, I think you guys are like right on the cusp. And in fact, the next thing on your line, Tom, is integration of NeuroGlancer with or of alignEM-SWiFT with Reconstruct Plus. So, literally that's the next thing on your list.
Yeah.
So the timing to me is just perfect for Joel to become also familiar with Reconstruct. So Joel, if you go to Synapse Web at clm.utexas.edu, I can paste that in the chat if you haven't already done that a bazillion times. Where's the chat? There we go. So that's where you can go. And then under tools, we have the software tool, and there's Reconstruct. And we've not implemented the 64-bit. We've literally abandoned trying to implement the 64-bit, basically in favor of Reconstruct Plus. But this works great on a regular Windows machine. And so then if you just download it, then you will get exactly, you just get it basically by clicking on it, and it downloads it and it becomes an executable. And somewhere there's the source. Here it is. There's the source. It's available on this GitHub clip for old Reconstruct. Can you see that if I roll in maybe a little bit?
Yeah.
Right. So then I was also telling you that there's a comprehensive user manual that Karen Soar and I updated in 2009. The one that gets loaded with Reconstruct is the original one that John wrote, but it's a little terse, but it's also available within Reconstruct, or you can, get further components. Let's see, if you look at the manual, but also I think even in GitHub, it's pretty well documented, the source code is, as I recall, by John. He really kind of did. He came from a background of industry code, right? So everything was commented. So hopefully things are mostly obvious. People like Michael Trillo have been able to go into the code now and, extract the data from the code and not have to use the interface. So, he's pretty green in programming. So I think it's pretty good. Anyway, I think giving you, sort of that access will help for you and Edwin and Shweta to really integrate with what Tom and Art are doing in alignEM-SWiFT and you.
Okay, so I think this discussion and what we decided today, I feel much more clear in my head, and I hope Joel and Art, you also feel more clear in your heads about what our path is going to be for the next couple months.
Sounds great. So Tom, I do have one question for you.
Sure.
At this point, I believe you have everything you need from Masa and John, or is there something that you still need from our EM team to move forward?
Well, a missing thing for Masa's. I sort of have, but it's not integrated into the whole scheme. Is using quadrangles as opposed to triangles to accommodate those sort of unanticipated types of wedge distortions.
Right. And I thought I had something in here alluding to that, but maybe not.
So you could just, when you go back to revise this, Tom, you could just work with Art and Masa to be sure you incorporate into your thinking and get into his timeline.
Right.
Whatever it is that you need to implement that.
Yeah. Now, there was something interesting that came up yesterday in our discussion with Art yesterday regarding, this is in the weeds of a little bit, but I just want to mention it just so you can see how deeply we've been thinking about some of this. So the ZAR format, you have a stack of images and you point at the images and you say, make the ZAR with a button press in alignEM, in the alignEM-SWiFT GUI, perhaps. And that makes a copy of your scale 1 images, brings it into the ZAR, and then makes all the other scales of images, and puts it in this ZAR container format. The current alignEM-SWiFT tool, what it does is it makes links to the scale 1 images. It doesn't copy them, it just makes links to them. And then it makes the other scale images by taking the scale 1s and scaling them down and writing new files. So it writes new files, and those new files are named the same as the original files, and they're files in the file system, and they're perfectly good TIFF or JPEG or whatever image format. They're perfectly good images, okay? In the ZAR format, your images are inside this container, and they're not immediately accessible as plain JPEGs or TIFFs, not directly, right? So my original, right, and alignEM-SWiFT, in alignEM-SWiFT, you've got the images in directories that are just plain files, and they're just plain directories and plain files of TIFFs and JPEGs. So when it comes time to do the alignment, we can just hand those images directly to SWiM, which is the image matching, the signal whitening image matching component of the SwiftIR toolkit, as images. And then when we make, and what SWiM does is it tells you where the images match, and then you use mirror to figure out if you have all these matches, here's what the affine transform is. And once you know the affine transform, then you can apply that transform to the image and generate an aligned image, which just then becomes another file on the file system, the aligned image. And then alignEM-SWiFT GUI shows you that image, right? In the new tool, the images are in this ZAR container, not immediately accessible directly as a TIFF or a JPEG, like I said. And when you make the aligned image at the end, that aligned image would have to go also back into this container. So what does this mean for what SWiM does, right? SWiM won't have access to TIFFs or JPEGs directly. How do we get those? So my original thought was, oh, this is going to be clunky, but we can do it. We can just export, get them and export them out into a separate directory, a temporary directory, give them to SWiM, and then get the affine transform, apply it to those. And then the result we have to put back in the ZAR container so that we can see it, right? But in discussion yesterday, Art was already thinking, that's clunky. There's got to be another way to go about it, and Art already knows what he's going to do about it. He's going to make a new version of SWiM, or update, add to the features of SWiM, so that SWiM can look inside the ZAR and get the chunks of data out of the ZAR and deal with and in memory put the image back together again. in memory, but without having to write a separate file. It can read directly from the ZAR. And when Mir generates the aligned image, it can generate the aligned image back into the ZAR directly. So
and this derives partly from the interconnectedness of the things that I'm working on at PSC side, as well as this project. So on the PSC side, we have these large optical images, of which we have like 30 petabytes at this point. And, data sets that are in the neighborhood of like 33 terabytes or so, that I'm trying to develop tools that will work in both of those domains in the same way. And
marvelous.
And
that'll be, really great for NeuroNext 2 Art, because, we've got scales of images from little itty bitty TEMs data sets to, Allen brain connectomics style stuff, which they are aligning themselves, but at the same time, future people might choose this environment as opposed to having to brute force it the way they did.
Yeah. And so I had thought that, that this would be an advantage, but maybe we wouldn't, it's going to take a while and it's not going to be available right away, but Art says actually it's not so hard to do. And so I think when we publish the paper, it'll be the version that works this way, in this very sophisticated way.
All right. Well, I think we're the time is sort of up right now. And I have to get a couple other things done before I leave on Saturday morning, bright and early. So thank you, Tom and Joel and Art and everyone else who's been working on this. I'm just thrilled at the really SWiFT project progress that SWiFT IR is making. I love to see this. We're back on, that steep trajectory. And, kudos to you, Joel, for picking it up so fast. But also, you got great teachers. So, not everybody could pick it up that fast without the team you got supporting you. All right, everybody. James,
Microsoft, I was saying absolutely.
Anyway, so we don't meet next week. Is that right, Anna Maria?
Yeah, that's correct. No meeting next week.
So
and then the following week, we have Tom, Art, and John discussing the outline of the GUI paper. The GUI.
That's what we did today.
Yeah, so that's what I kind of realized during it. So,
this is our current role. So
in 2 weeks, let's see, next Thursday, you should look at, maybe the thing to put there is not this, because this is what we just talked about today, but John giving us progress on TomoSem and, with his relationship with SAIS, et cetera. What's happening there. Is that reasonable, John, in a few weeks?
Well, we could also tie into what we discussed today and
sure.
How in future what we might expect from a Tomo set would fit into the...
I would love very much for you to begin to integrate the thinking about Tomo. And the reason for that, too, is that in the big picture of this whole effort, we really want the virtual sections to be dialable in this environment as well. So you can say, okay, it came in at a Z of 50 nanometers. I want it now to be each section 2 nanometers. And I'll tell you, Michael in his dendrite project, inhibitory dendrite project, has figured out how to calculate that based on the smooth Z trace from Reconstruct, and to basically he can't visualize it, can't look at it at a different section thickness, but he can quantitatively analyze it at a different section thickness. Well, so Art's been talking a lot about how to think in the future to make the virtual sections. I think that's going to be a good component to discuss too. But anyway, for now, I don't think if you want to keep going with this again in 2 weeks, I think maybe you might want to skip a couple of weeks before we come back to let you have some time to finish working on this part of the paper and move a little bit to the TomoSem different project giving us some progress report on that. How do you feel about that, John?
Yeah, sure.